Hi folks, welcome back to another stats video. And in this video, we're going to talk about the skewness of data, okay? That's sort of a funny looking word or funny sounding word, so let me write it at the top. We're looking at skewness of data, okay? A quick review about skewness. So you can find this in section 2.6 in your textbook, but sometimes we end up with data sets that are more or less sort of symmetrical like this, okay? There's sort of a clear middle, the middle is in the middle, and then everything is sort of even on both sides, okay? But every once in a while, we'll see data where we call one side is sort of pulled out a little bit, okay? And so if we have data that kind of looks like this, all right, we call that skew right. All right. I know that's weird because the bump is on the left. Okay. But what happens is we have some outliers here that sort of pull the data to the right. Okay. The other way can also happen. Maybe we have a data set that looks something like this. All right. So the bump is now further to the right, but we call that skew left. Right? And the reason why we call it skew left is not to make it confusing for you, but because these outliers over here are actually pulling the mean to the left. Okay. All right. So now that we've got that image in mind, let's take a look at the question. So it says, discuss the mean, median, and mode for each of the following problems. Is there a pattern between the shape and the measure of the center? Okay. So let's take a look at A. In this figure, we've got the number of gold medals won by country in the 2010 Winter Olympics. And so if I look at this data, all right, and I wanted to think, okay, is it skew right, skew left, or neither of those? I think we can see that if we sort of highlight over the bumps, that we end up with a skew right situation, okay? So this one is skewed right, right? And what that means is that we have some outliers on this right-hand side, okay? So like in particular, we have a country that won 14 gold medals. And so that 14 pulls the mean to the right, okay? Now, you don't have to do this, but if you went into StatCrunch and you put in all these data values, okay, so like 0, 0, 1, 1, 1, 1, 2, 2, 2, 3, etc., etc. If you put those all into StatCrunch, what you would find is that the mean, all right, would come out to be about 4.2. All right, so if we added them all up together and divided, we would get 4.2. But if we line them all up in order and then found sort of the middle of that, which we call the median, right? The median turns out that that was 3. Okay. And we could use StatCrunch to find the mode, or remember that the mode is just the one that happens the most. And so the mode here is 1. Okay. Now let me mark those off here. So we've got our mode, all right, our median, and then somewhere in here is our mean. Okay. And so we can see that the mean has actually been pulled to the right. It is the biggest value out of all of them. And it turns out that in a case when we have a skew right situation, the mean is going to be bigger than the median because it's been pulled to the right. And then most of the time, the mode will be the smallest because most of the data points are sort of in that left bump, okay? So let me write that down for us because that was kind of a lot. But if we have skew right, it usually means that the mean is, how do I write this? The mean is, I didn't leave myself enough space. All right, well, let's write it down here. The mean is bigger than the median, which is bigger than the mode, okay? And all of that happens because we have these outliers on the right that pull all the data to the right, okay? All right, let's take a look at B. So in B, we have the ages former US presidents died. And even though this is a stem and leaf plot, all right, so we've got our stem, we've got our leaves. If we sort of tilt our heads to the right, we can sort of see that we have something that is pretty symmetrical, okay? And in the symmetrical case, all right, so this one is symmetrical. Symmetrical meaning that it is not skew right and it is not skew left, right? It's just sort of even on both sides. And when it's even on both sides, the mean, median, and mode tend to be close together. All right, so these measures of central tendency happen to be somewhere in the center, okay? We don't have any weird outliers in the sense that we don't have a former US president yet who maybe is like 120 years old, right? If we had someone that was 120 years old, then that would be sort of like this skew right in the Winter Olympics because now we have this outlier all the way on the right, okay? On the flip side, if we had a very young president who died, right, unfortunately, let's say we had a president who died at 30, that would be more something like this, where we've got an outlier all the way on the left, and that's going to pull the mean to the left, okay? All right, let's take a look at one more example. So over here, we've got hours spent playing video games on weekends. And we see that we've got 2 people who are doing 0 to 5 hours. We've got 3 people who are doing between 5 and 10, etc., etc. Okay. Now, I think we can tell from this that we've got a skew left situation. Okay. And we've got a skew left because something over here, we've got some outliers that are pulling that mean down to the left, okay? Now, again, if I put this all into StatCrunch, and you don't have to, but if you do, you'll find that the mean is about 16.1, all right? So the mean is about 16.1. You'll find that the median is about 17.5, okay? And so we can see that would mean like the mean would be like here and the median would be here. All right, so which one is smaller? The mean is smaller than the median, but where is our mode? I don't know the exact data value, but I know that most people play between 20 and 25 hours per weekend, okay? In fact, 9 of the people play between 20 and 25 hours per weekend. So our mode here is clearly the biggest. So we've got mode is going to be bigger than our median, which is going to be bigger than our mean when we're looking at a skew left situation, okay? Because wherever that bump is, this bump is where that mode is. That's going to be the biggest value. And then any outliers down here, it really pulls our mean down to the left. Okay? All right, let me get this all on one screen for you so you can take a look at that. Woo. There we go. All right, let me know if you have any questions.